I hope my screen is visible. With that, okay, there's some issues with sharing. Yeah. Hey, hi everyone. This is Sandiapn. I'm a DevRel engineer at Shardeum. Today we are going to go through a brief about what Shardeum is, what kind of problem it solves, and how you can build decentralized applications on top of Shardeum. It's going to be a pretty basic workshop. I got to know about the target demography here. So many of you are, I expect, are new to Web3 itself. So I will try to like make this as simple as possible. But yeah, like having a brief context about what a blockchain is, how a basic blockchain works, should definitely help you in this workshop. But also, like you can check that out later. Like even if this is the first time you're hearing about Web3 and about a blockchain. So yeah, Sharding is a decentralized blockchain network. And today we are going to learn on how we can build decentralized applications on top of it. So yeah, let's get this started. So let's start with the problem statement first. Like, what are the biggest problem statement in the blockchain world right now is scalability. Like whenever we are talking about new technology, we want this to be accessible by as many people as possible in throughout the world, no matter how much internet connection they get, no matter how like the connectivity is there or the financial situation in different parts of the world. We want the applications to be accessible to everyone, not only cost wise but also infrastructure wise. So one of the biggest problem which current blockchain networks are having is that they don't scale. By scaling, I mean that whenever there's a huge network traffic, the blockchains have a fixed limited number of TPS and they max out at that TPS and that's it. To give you the context, like Visa processes, the Visa payment network processes more than 200,000 transactions per second, that it has the capability of doing that, even more than that. But most of the popular blockchain networks right now are doing 16 TPS or 20, 25 TPS. So there's a huge gap in what the general market needs and what the technology has come up with. It's not a bad thing also. Like initially, like we will start with low TPS. It's a new technology relatively speaking to the like advent of internet, but there's a problem we also need to address, that existing blockchains don't scale. And whenever through this chart, like it's a very simple basics chart, you'll see whenever the demand grows, the UX is dropping. By this, I mean, whenever there's a demand in the network, that there is more transactions being sent to the network, people's transactions are getting stuck. The gas prices, basically the price you pay to get your transaction into the blockchain ecosystem, like the gas prices shoot up. Like no one, like if you want to do a $2 transaction, if the gas price is $10, it makes no sense, right? So that's the kind of problem current existing blockchains are having with demand. They're not able to scale as that much. With Shardium, Shardium is an EVM-based layer one linearly with dynamic state sharding. This is a pretty big statement with some confusing words, and we are going to break it down and one by one and learn more about it. So EVM based. If you're entirely new to the ecosystem, one of the most popular blockchain which introduced the whole smart contract features is Ethereum, and Ethereum runs on like the EVM, Ethereum Virtual Machine. It's basically a decentralized compute machine in which like all the nodes get together and it's Turing complete. So any kind of logic can be executed on top of the EVM. Just consider EVM as a machine with compile the code and execute the logic. So Sharding based layer one that scales linearly with dynamic state sharding. Um, there are multiple layers of blockchain. There are layer ones, there are side chains. Like all of these is combined together and form an ecosystem. And in that aspect, Shardium falls on the layer one part of the world, and that layer in which like, there is no other separate layers or layer twos needed, and it acts independently as a primary layer. The layer one is like Ethereum. And yeah, of linear scalability. This is also something I think in my like as we go down the slides, we will get to know more about it. But linear scalability is the basic idea is that with every new addition of nodes, the transaction per second increases. So like just as I mentioned in the last slide, that whenever there is like all the existing blockchain networks have a TPS capacity, and whenever it hits that, it reaches that maximum point, and that's it. Like it cannot go move beyond that. But with Shardeum, with every new additional nodes to the network, the TPS also increases linearly. So if there are 50 TPS, like if there are 50 nodes in the ecosystem, I think someone is speaking. Yeah, no worries. So yeah, if there are 50 nodes, then we will have 50 TPS. If there are 10,000 nodes, we will have 10,000 TPS. That's the linear scalability part of it. So dynamic state sharding enables Shardeum to increase its TPS capacity with each validator. Now, Shardeum is based out of a technology called sharding. Sharding is basically how we can do parallel transaction processing. Like the problem which I mentioned again in the slide. In any given amount of time, the network gets jammed at a certain TPS whenever a certain TPS. In Shardeum, we use a technology called sharding. Sharding is not a new technology in web, like in the whole internet aspect, but it's a new, relatively newer being executed in the blockchain world. So I think even in Web2 space, I think sharding is a popular concept in which used to scale your databases. And basically in dynamic state sharding here at Shardeum, the blockchain is divided into multiple shards. So multiple shards, a shard can consist of a number of nodes, for example, 12 nodes. And if a blockchain is made out of 1200 nodes, then with 12 nodes in each shard, there are 100 shards. And each of those shards can act as an independent processor of the transaction. So instead of the entire network coming together and processing that again same transaction and coming into consensus, the transaction is now distributed into a group of shards, and each shard can take its own share of the network load and validate the transaction and process them accordingly. So that is one of the primary code tech behind Shardeum, which uses the dynamic state sharding. And yeah, there's a TPS per node we already discussed about that. With every additional nodes, the TPS increases. And with that, like the whole idea of Shardeum is that it needs to be completely decentralized and secure. In the decentralized and secure in an aspect that we don't have eligibility criteria to run a node. The idea is that anyone from the community can join together with very little and we have a very light consensus mechanism, so that you can even run a node with even basics of machine, which even your home in a home computer itself. So the entire thing about decentralization is that, as I said, it needs to be accessible to all parts of the world, no matter where we are talking about. So like anyone in the world able to spin up a shard node, and the higher the amount of nodes we have, the more amount of decentralization we get, and thus the more amount of transaction processing power we get. So that's the entire point of decentralized and secured, which we are building on top of like Shardeum. Yeah, so let's address the elephant in the room. What is dynamic state sharding? As I said, this is a brief introduction on how a basic kind of a blockchain works. With every address, this is a wallet address. Like the balance are associated with this. So there are different wallet address and there are different balances which are associated with this. This is, for example, in any other common blockchain you would see in the market. And same for like, this is an example. And same, we have multiple shard in the network. So at any given point of time, each given shard will like cover a specific range of addresses. For example, in this case, this shard covers this address, and this address. Then again, in this case, this shard covers, again, this address, a different address, and then a different address. So at any given time or point of time, each of the addresses in the network will be covered by different amount of shards, so that we have a redundancy that like at any given point of time, so for example, a shard is not goes down, or a validator leaves the network, you don't get dependent on only one of those, so that like even your transactions can get mined even if one of the validator chooses to leave the network at a certain point of time. So there is a multiple redundancy, so each shard covers different range of addresses at the same time. This increases, and instead of like what we discussed in the previous slide before, instead of just each of the node covering all of those, we are dividing it. Thus, like we are increasing the linear like computation capability of Shardeum. So that's with the key technology and the key problem which dynamic state sharding is solving. Again, with another shard, it's covering a different range of addresses. This can get a little bit like, to explain, if you're hearing it for the first time, it can be a bit confusing, but I will later go to the docs, the Shardeum docs, and you can do like more in-depth reading on top of that and understand the concept of dynamic state sharding over there too. But it's not that complex of a topic, to be honest. And like, if you go through it once, I'm sure you won't be having much trouble in that case. So yeah, that's basically what dynamic state sharding is. And again, another new feature which like Shardeum introduces is autoscaling. With autoscaling, like how the Shardeum architecture is based is like, there are two types of validators: active validators and standby validators. So whenever a network is running, this black dots are represented by the active validators. So for example, there are 750 validators in the network, and they're processing the transaction. And these white dots are the standby nodes, which are waiting to join the network. And these are like randomly switched at a given point of time. At a certain point of time, some of the nodes will go to standby, and some of the standby nodes will come into the active pool. And this auto rotation keeps happening. So with Shardeum, one of the key things on how we are solving the scalability problem is that at every 60 seconds, the Shardeum nodes take a brief capture, not even a capture, I would say, like they go through the network traffic. What is the demand of the network? Is the network demanding 750 TPS? Is the network demanding 1000 TPS? What is the transactions that are coming through? Based upon that, the network is smart enough to bring in a necessary amount of nodes into the active section to process those transactions. So if 750 TPS is needed, it will bring in 750 nodes and keep the others in standby, and 750 TPS is being achieved by the network. Then, for example, again, a new spike came up in the processing part. Now 1000 TPS is needed. In this case, it will bring in more standby nodes into the network, increase its scalability power, increase its TPS, and now we have more TPS into the network. So by switching this like between the standby and active validators, Shardeum achieves this linear scalability and scaling feature. This is a pretty cool feature, to be honest, and it's not been implemented like in most of the blockchains which are aiming to solve scalability. Like this is a very cool feature which we get in Shardeum, and that is why like we are able to achieve with linear scalability and auto scaling. Again, a new one new composability. There are a lot of words. It's a typical like a complex topic, I would say, in general. But because like there are multiple new words I'm introducing into this workshop. But if you Google, even just go to Google and Google these words and read through those, I'm sure like you won't be having that much of a trouble. But I'm still trying. I will try my best to explain these complex terms in as simple way as possible. So with atomic composability, let's just see and how a transaction goes from the wallet to the network. So for example, you have a wallet here with some SHM tokens. Now the transaction, you interact with the front end application of a decentralized app. That transaction, which just made into the front end, gets added to the access list. So Shardeum has an access list feature, and which works automatically. Basically, the access list is whenever a new transaction is being sent to the network, that transaction has details of what are the contracts, what are the people involved in that transaction. Because as I said, Shardium is a sharded network. So each shard may or may not know about what is happening on the other shard. So in this access list, for example, you are doing a token transfer from A to B, and the token lives on one shard, and the party you're transforming, that address is being covered by a different shard. So with that, like whenever you send a transaction to the Shardium network, that access list will contain the details of all the people involved in that transaction, and that will be sent to the Shardium RPC URL. And through that RPC, the transaction is being sent to a validator. These are individual like shards, I would say, multiple nodes teaming up to form multiple shards. And then those shards, different shards together, form the entire Shardium network. So this is a typical life cycle of how a transaction, like how a user goes from the wallet to the block transaction goes to the blockchain. With atomic composability, one of the, I would say, which Shardium brings, is that no matter if your smart contract lives in this shard or if your address lives in this shard, the network is smart enough to, because of the access list feature, the network is smart enough to bring in all the people involved in the transaction and do the consensus in general. So that is basically what atomic composability is. So you don't need to worry about which shard your dApp lives on or which shard your user is on. Like the communication happens seamlessly. And like this has been a very difficult challenge in the sharding world. And this is a pretty cool piece of technology. Like it's a very complex under the hood. But for dApp developers like you and me, like this is basically how like we need to know about it. We don't need to get it because that already like you don't need to worry about where applications live on what the people you are transacting with. Again, like the reasons developers are gravitating to the like, I think so far I think short workshop um, begin. So we are at a testnet right now, and we are in line to go mainnet in second quarter. So like we are a beta in hello. So as I mentioned, I think dynamic state sharding is the key like tech behind Shardium, in which like in a general blockchain you have all the different nodes. For example, each of these represent a node, and all of the different nodes are covering all of the different addresses. This includes like introduces a redundancy in the network, in which all the different nodes need to know exactly about what's happening uh, in the entire network, of what other transaction anyone is doing, and everyone needs to come to a consensus and validate the transaction. The idea behind dynamic state sharding is that instead of needing all the different nodes in the network to act on that consensus, in Shardium, the interesting fact is the consensus is done at the transaction level and not at the block level, like most popular blockchains do. With that, like why at the transaction level? I think because the network is sharded, as I mentioned, like the network is divided into multiple different smaller blockchains, like multiple different shards. That is why like doing consensus at block level gets difficult and even redundant. Like if doing it at block level slows the network down because you need to wait for every one of the nodes to come to the consensus. So that's the key like benefit of doing transaction level consensus. And also like with that, you get atomic composability, which I will cover next. But yeah, like with dynamic state sharding, each of these represent a shard, and each of the shard cover different set of addresses. So for example, this shard covers this, and this address. And then this shard covers, again, this also. Address can be covered by, like, it can be not, like it's definitely covered by multiple shards, so that even if one shard or a group of validators from one shard decides to leave the network, you still have the details, and like you can still work on all the addresses which are being covered. So yeah, like each of the shard can be covered by multiple addresses, and even each of the addresses can be like covered within a simple, like one shard. So that introduces a, like, reduces the redundancy of the network. And with that, instead of the entire network add together coming to a consensus, um, like you just need like enough like validators in a particular shard to come to a consensus. Like we will talk about like atomic composability in the upcoming slide, but to get into more details about that. The basically an auto scaling is one another feature of Shardeum. With auto scaling, like the Shardeum architecture is designed in a way there is always some active validators and standby validators. So whenever, like for example, you need 750 TPS in the network, the Shardeum network is smart enough to gather information into the network of what the network needs, like what TPS the network needs at any point of time. And yeah, the net at any point of time, and then it automatically brings in or removes nodes according to that, and that is basically the auto scaling feature. So for example, if you need 750 TPS, the network is smart enough to bring in enough nodes and achieve that 750 TPS. And then if you need 1000 TPS, it will bring more nodes from the standby section into the active section and achieve that 1000 TPS limit which the network currently needs based upon the demand. So that is the like a pretty cool feature which Shardeum has of auto scaling based upon the network demand, and that is basically what we need day to day real life. We don't need 1000 TPS when the network needs 400 TPS. We don't want the network to do 400 TPS when there is an important event happening, a popular NFT mint happening, and the network needs to scale. We need 2000 TPS. The network automatically gathers the info and reaches that 2000 TPS. So that is a pretty cool feature which Shardeum has, auto scaling. And yeah, regarding atomic composability, let's just go through the brief on how from one part to the other, like a transaction, like a user, starting with how the user interacts with the dApp and goes to the like that transaction gets to the added to the blockchain. So there's a wallet. That wallet interacts with the front end of an application. Then that front end, once you do that, do the enough, like the required necessary steps on the front end of the application, there's an access list feature on top of Shardeum in which whatever, like since the blockchain is sharded, the access list will contain the list of all the addresses of the particular transaction. For example, if you're doing a swap, then the smart contracts may live in one shard. The user address are being covered by other shard. So that access list will cover all the, like will contain all the info of who a particular transaction deals with, and that will be like the main like decider of which are the shards that needs to be brought in for that particular transaction. And then that access list combines it and sends to the Shardeum RPC, and that RPC introduces it on the Shardeum node, and that Shardeum nodes form to group together and form a shard, and multiple shards group together to form the entire Shardeum blockchain. So that's basically a life cycle of a transaction on top of Shardeum. And the point of atomic composability is that, as I mentioned, maybe the swap contract is in one shard. The sender address is being covered by another shard. The receiver address may be covered by another shard. So how do these shards communicate all together? They communicate all together because we have that access list feature, which maintains the records that which are the shards and what are the addresses which are being covered. And that is how atomic composability is being achieved. The basic definition of atomic composability is that the user or the developer doesn't need to worry which shard their application or the user lives in. They just need to like deploy their dApp just like any other EVM compatible dApp. And like that is one of the key features Shardeum is bringing onto the like scalability problem. That like you see multiple like other blockchain in which each of the user needs to join or change the network details according to the shard, each of the shard. Like that is not a good user experience. Like you need to figure, okay, my shard is living in this blockchain, like this shard, my blockchain app is living in this shard, so I need to do this shard. In Shardium, it all happens automatically because of that access list feature, and that is how atomic composability is being. I hope my network has been doing good so far. Yeah, awesome. Yeah, so reasons why like you guys like in any Web3 ecosystem, developers are one of the most important part of that ecosystem because like without applications, a blockchain won't have its will find its purpose. So we definitely need more developers and like Shardeum has been growing pretty good in the developer community, and that is why like some of the reasons developer are gravitating to the Shardeum, like the auto scaling features. It's AVM based. Many of you are already like some of you, I would say, are already familiar with the Solidity language, in which you need to build the smart contracts on top of Shardeum. So it becomes easier for developers. If not, if you're an entire beginner in this endeavor, then like Solidity as an introduce, like if you have JavaScript knowledge, like Solidity can be learned pretty easily. So like you won't be having that much trouble. And yeah, atomic composability, you don't need to worry. The neither the new user nor the application developer needs to worry where which shard their app lives on. Like it all happens automatically. Users like Shardium testnet is one of the most popular testnets out in the world right now. And like we haven't even launched our beta net, and like users are migrating. So like we need there's a lot of demand for a lot of dApps to be built on top of Shardium. So that there's a very good opportunity for you to build on top of Shardium. And yeah, I think even Short mentioned in the beginning of the workshop, Shardium has been native to India, like one of the biggest Web3 community. We have started our developer community from India, and we are expanding globally throughout the world. And that's the beauty of working in Web3 and like being a Web3 developer is that no matter which country you are from, no matter where you are from, you can build an application and go global like overnight because there are no restrictions. Your application lives on the blockchain. So that is the beauty of it. So like the opportunities you get in Web3 because of it being a decentralized ecosystem is why like we are definitely uh, proud of the Sharding community. Um, so yeah, like definitely these are some of the reasons developers are gravitating towards Shardium. And now let's get to the Shardium docs. Let me hide this bar. It's getting in front of me. Yeah. So yeah, if you go to docs.shardium.org, this is the okay. I'm sharing my whole screen, right? I hope it's visible. Awesome. Yeah. So if you go to docs.shardium.org, this is the URL for our documentation. As I mentioned, like if you're hearing many of the things for the first time, and if you're an entirely new developer, like a Web2 developer who is new to the ecosystem, some of these may still not be very clear to you. So you can start with the docs on what is Shardium. You can watch this brief video explaining explaining about Shardeum, how the transaction consensus happens. Like Shardeum uses a combination of proof of quorum and proof of stake, and each of these consensus algorithms are unique and like interesting of their own. So you can learn more about those two, and yeah, so you can everything lives on the documentation on top of Shardeum. Like since the most of the audience here are developers, I guess like this will be the most interesting part in which you go. And as I mentioned, Shardeum is EVM compatible. So Solidity is the language you use to write smart contracts and build applications on top of Shardeum. The front end remains same. There is no new kind of front end infrastructure to build in. Like you can use React, via like Vue, those kind of frameworks. But the backend in which you are actually writing the smart contracts, Solidity is the language which are used on top of Shardeum. And as I mentioned, like it is influenced from C++, Python, and JavaScript. So if you are familiar with these kind of languages, like jumping onto Solidity should be pretty easy. But yeah, like this is the OG document of solid like language. I know like in general, most of the people don't learn a particular programming language from documentation, but like this is the biggest and best resource to learn Solidity. It can get in depth and can get a bit confusing, but like this is the master documentation, like the master Solidity learning resource. Apart from this, like there is also Solidity by example, which you can use to just quickly iterate on the different kind of application. So for example, starting with the basic hello world application on top of Shardeum, like you can deploy the smart contract on top of Shardeum. And there are multiple examples of if-else mapping, like common programming concepts on how you can achieve those using Solidity. So these you can definitely, I will recommend to go through this while you're deploying, like building on top of Shardeum. And that's basically all you need to know, I think, about Shardeum and to get started, start your journey as a developer on top of Shardeum. This is remix.ethereum.org, an online IDE, which I will just quickly demonstrate on how like you can just like I will live demonstrate on how you can just create a transaction on top of the blockchain and deploy your own program, which cannot be changed by anyone else once deployed on top of the Sharding blockchain. It's a pretty basic smart contract. This is how like Solidity smart contract is being written. Like this is the structure. As I said, like all of these you can learn from the Solidity documentation. But yeah, like we have the contract mood diary, and like we are defining a string of mood, and then this is a setter and getter function. We have a function with set mood, which takes the string memory, and it's a public function. It means that like anyone call this function, and then we have a getter function. This is a pretty basic 101 kind of a contract which everyone starts with. And I think even in the Web2 world, we have a function like when you are learning JavaScript, like we have a getter and setter function. This is similar to that. Just the only difference is that we are going to do this on top of a blockchain. So let's just compile this smart contract, and it's compiled. So let's just deploy it. So instead of the environment, I'm going to choose injected provider MetaMask. MetaMask is a like wallet, so you need wallet to interact with the Stadium testnet. And yeah, I'm a Sharding testnet whale. As you can see, I have 20,000 SHM, so it's testnet anyway, so it doesn't have any real value. But yeah, like if you guys need testnet tokens, you can go to the Shardeum faucet. This is the faucet. You need to tweet out a basic tweet. This is for verification so that the faucet is not attacked by bots. And you need to put your wallet address and just claim the SHM testnet tokens. And once you do that, you should be able to deploy on top of the Shardeum network. So as I said, like once we select the injected provider, now you can see the Shardeum is like custom 8081 network. the network endpoints can be found here. So we have two different testnets right now, the Liberty 1.x and the Liberty 2.x. The only difference is Liberty 1.x was the previous testnet, and it is an unsharded network, and the Liberty 2.x is the like the sharded network, and this is more close to the actual blockchain, which will go mainnet. So I will definitely recommend you to use Liberty 2.x. And yeah, these are the network details. You can add it onto MetaMask. Again, these are the some of the like things you can find out in the wallet on how you can configure your MetaMask and all. So I'm not going into that depth. And let's just if you once you are done setting up your MetaMask and you have this showing that custom 8881 network. Why 8081? Because this is the chain IT 8081. So let's just deploy it. So whenever I click the deploy button, okay, timeout happened. Let's see. Let's just quickly compile. Hmm. So let's just choose injected provider. Yep. Yeah. As you can see, the MetaMask pop-up came, and I need to pay a gas fee. So any write transaction on the like writing transaction, writing and reading are two different actions. To write on top of a blockchain, you always need to pay gas fees. And I just paid the gas fee, and the contract is now being deployed onto the Shardeum testnet, and it will be deployed and it's already deployed. So let's just make it a big. So yeah, it's in the block. You have the block address. So although transactions don't happen at the block level, like the consensus does happen in Shardium at block level, we still form blocks. This is the transaction hash. Let's search. And as you can see, the transaction was successful. It was created a minute ago. It's a smart contract type. And yeah, this is the transaction hash. This is the contract address. And yeah, that's pretty much how you can deploy a smart contract on top of Sharding. And yeah, I think that is very basic demonstration. I didn't like my main focus was to um, showcase on how you can like learn about Shardium and like the basic architecture on top of Shardium. I'm sure you still have a lot of doubts. So okay, yeah, I will read the chat once I end the workshop. But yeah, so yeah, this was a very basic demonstration on how you can deploy a simple smart contract on top of Shardium. There's a lot more on beneath these. Like you can again, and everything is mentioned in the documentation. Definitely check it out. And like if you are learning, if you're getting into Web3 for the first time, Solidity is a great language to start with. And yeah, I think it is a pretty comprehensive language and pretty interesting to write and pretty fun to write. And like, let me know on how I can help. This is the online IDE which we have used. You can also use Hat. It's an offline, like a tool in which like an entire like development environment in offline. In your VS Code, you can start with that, and you will have the Hardhat documentation here also. So with Hardhat, you can start building out your application. With the folders, there will be smart contract folders. There will be a front end libraries, and that's where you can start building a full stack application. But initially definitely start with the remix, build some basic contracts, go through the Solidity by examples, and execute them in the remix and see and try to make some different variations and see how the blockchain reacts. And that is basically how I learned. So, and once you are comfortable with remix, you can jump onto Hardhat, the install Hardhat. The entire tutorial is here on how you can set up the environment, how you can create a Hardhat project, deploy to the live network, and do documentation on top of here on the network details. You need to put that in your Hardhat config files, and you will be able to deploy from Hardhat into the Shardeum blocks. So yeah, that's pretty much it. I would say on how you can start building dApps on top of Shardeum. Definitely join the Shardeum Discord server. That's where all the developers hang out in the Shardeum community. And yeah, that's where I will also be available. So you can always DM me there, or you can interact with other developers over there. And that is a basic conclusion of the workshop.
Yeah, and some questions that I know some
Yeah, I can
asking.
go over to the Sharding.
Yeah, I wanted to
Yeah,
get
yeah. For the like ecosystem. So that's yeah. Go ahead.
no, you're already on it. You're already in it. I wanted to know because a lot of people are already know some Solidity developments. So yeah, they're looking what from other existing applications, whether it be on Ethereum, Polygon, Avalanche, Celo, or any other EVM, can be deployed and how it can fill the gaps in the ecosystem. So
Yeah, yeah. So like as I said, Shardim is as it's testing it right now. There's a massive potential for any of the project that's coming up to be the biggest project whenever we go mainnet. So like there's a huge potential of that. Like we already have, as I mentioned, a pretty active community with a lot of users which are hungry for applications. So like it's the other way around in general. You don't have users in most of the blockchain, and there are a lot of dApps. But like starting from like at the beginning of the Shardiums, whenever Shardium was formed, like we had a strong community support. So there's a lot of users who are hungry for getting good applications on top of Sharding. That's where the opportunity comes as a developer. So yeah, you can go to ecosystem to check out all the current Shardium dApps. And like if any of them is built on top of any of the other EVM system, as I mentioned, the switch is pretty easy. We are totally EVM compatible. So the only change you need to make is the endpoints in your whichever format you're using, your Yada truffle or even from the remix. Like you need to use the RPC URL of Shardium and just deploy your contract on top of Shardium, and you're good to go. Like that's how it is because EVM out of the box. So if you have already built application on top of other networks, like the switch to Shardium is super simple, and just switch the RPC URLs, the chain IDs, and you're good to go. Yeah, and yeah, like there's a lot of big, as I said, big opportunities. There's a lot of infrastructure tools, Texify dApps you can build, which Sharding needs right now, and who knows, it will blow up to be the biggest application on top of Sharding. That's the potential that any ecosystem project in Sharding right now have. So should I, let me drop this link in the chat so that you guys can go through it. And also, like as like, if you want to check out like the transactions I think in considering in web, I think Solid is part of a compulsory tech stack. It's becoming more and more a part of a compulsory tech stack. So Shardium would support Ethereum token standards. Yeah, totally. Like as I said, it's EVM compatible. So ERC20, ERC721, like any of the EIPs, which are like popular EIPs you can think of, you can directly build out of the box in top of Shardium. I can see two Liberty Explorers. Yeah, as I mentioned, the 2.x network is the sharded network, and it's much more closer to what you will have in the actual mainnet. So use 2.x network in your, and 1.x will soon be deprecated anyway, so use 2.x while building on top of Shardeum. Yeah, I think that's I have covered all the messages, right? When is the roadmap for mainnet? So mainnet is expected to go live on Q2 of this year. And as I mentioned, like in 15 days, we are having a pretty big update, the beta net upgrade, in which like you can start running your own validators and join the Shardium testnet networks. So that is a pretty big update. And after that, Q2 of this year for mainnet. So you have a pretty good amount of time to build and test out your dApps testnet before mainnet, and from your dApp you can go on mainnet together with us. So yeah, it's going to be a pretty exciting journey.